The second part of this associated with environmental safety is the ecotoxicity portion. And really, you can assess ecotoxicity by two means. BPI requires the toxicity test be performed with 2 different plant species. Other regions of the world also consider earthworms. Again, similar to the plant species, you expose the earthworms to compost that's created with a test item, and you look for a negative effect on those earthworms. And really, the compost that's created during this process cannot do any harm at all to any living organisms. And that's a very important point. So we always compare these to control materials, which is compost that's produced with in the absence of a test material, and we look at the difference in performance of that compost. What I really want to highlight here is the stringency of this testing. When we make compost for ecotoxicity, we do that with a 10% input concentration of the test material, which is a very high concentration. And to give a quick example of that, using a coffee capsule example, a typical coffee capsule weighs about 1.5 grams on dry weight basis. In order to make compost at a 10% input concentration, that requires the addition of over 5,000 coffee capsules be added into 80 kilograms of bio-waste, which is equivalent to about 30 capsules per day per person of coffee. That's a tremendous amount of coffee for any individual to actually consume and then put all of those capsules into a composting environment. So it's a very high input concentration. Visually, this is what a 10% input concentration looks like. So the picture on the left here shows 1.1 kilograms of test material added into 11 kilograms of fresh bio-waste. And you can see from this picture, this is well exceeding a typical concentration of material that would exist in a real commercial composting facility. And the point that I'm trying to make in all of this is that the laboratory testing stringency is much greater than those conditions that actually exist in real-world commercial composting facilities.